Okay, so this is our first video on geometry, and it's important. We're dealing with geometry, the study of shapes, right? That we understand some terminology. So we're going to go over a little bit of that right now. A point is just a singular point, like a dot, like right here, this point right here, this point right here, okay? If we have 2 points, right, they could be like here, right? And I connect any of these 2 points, whether I do it here or if I do it like this. Okay, we have 2 points on either end being connected. This is called a line segment. All right, I'll try to make these points really big so it's clear. Okay, this is called a line segment. If we have a line that extends from a point in any direction with an arrow, okay, this arrow tells us that it's going to go on forever. So when we have an endpoint on one side, but it's going to go on forever in another direction, we call that a ray. And then lastly, a line is when we have arrows on both sides, meaning it's going to go on forever in both directions. We can throw points into that line if we want, right? Now, on this line, if we had point A, right, we can label our points. So let's call this point C and this point D, okay? Let's put some points here as well. And the reason that we want to put points here is because then we can name these. I want to show you how we name them. So CD, let's call this E and F. Okay, so this is a line segment. I could show it as line segment CD, right? Or the ray EF, right? Or in this case, the line AB. Okay, so the next thing that we're going to talk about is angles. So if you imagine we have this point here, A, all right, and let's draw a ray going out. And we'll put a point on that ray, let's call it B, okay? And then let's draw another ray, like this. Okay, and let's put a point here, let's call it C. So what you'll notice is now we have an angle, right? And we can describe this using degrees. Okay, so when we think about degrees, we think about a 360, right? If I do a 360, I'm facing you right now, 360 degrees, I turn all the way. So we can think about that here too. If I was facing this way, and then I turn all the way until I'm facing this way again, that's 360 degrees. So what that also tells us is that if I have a cross like this, right, what's 360 divided by 4? Because each of these angles are the same, right? 360 divided by 4 is 90. Okay, 90 degrees. 360 degrees for all the way around. So each of these is 90 degrees, okay? And these have a special name. These are called right angles. So we know that if something, right, makes a perfect corner, essentially, it's 90 degrees. We call those right angles, okay? So what that also tells me is that if I have 2 right angles put together, right, here's a right angle and here's a right angle, well, then the measurement of this whole angle, right, a straight line, well, that's 180 degrees because 90 plus 90. So a straight line, right, is equal to 180 degrees. So if we look at this angle, right, we could try to maybe estimate, well, what's the value of this angle, right? If this ray here were going straight up, right, if it were perpendicular, we'll talk more about that later, then it would be 90 degrees, right? This looks like it may be a little more than half, so we could guess maybe this is 50 degrees, which would make this angle here, 40 degrees, right? Because together, these 2 angles make a right angle, okay? And we always put this box here to show that. So together, these 2 make a right angle. So if this is 50, this is 40, all right? when two angles, if angle 1 and angle 2 add up to 90 degrees, we say that they are complementary angles. Complementary angles. So let's go ahead and name each of these angles, right? These two angles are complementary. Well, what are the name of these angles? This one here, we name it, and the point from which both the rays are going, we call it the vertex. Okay, the point that is the vertex always needs to be in the middle. So this here is angle CAB. Okay, CAB, or I could call it angle BAC. Either one is acceptable, right? BAC or CAB. But notice that the vertex A is always in the middle. So what would I call this angle here? Well, this is either angle DAC or angle CAD, right? But either way, these two together are complementary. Okay, the other situation that's important to know is what do we call it when two angles make a straight line, right? If two angles together make a straight line, that means they add up to 180 degrees. So notice that these two angles, right, if I combine them, add up to 180 degrees. So if I told you that this was 30 degrees, right, they could say angle, for instance, angle CAB and angle DAC are supplementary. Okay? Complementary means they add up to 90. Supplementary means they add up to 180. They form a straight line. So they can tell you, all right, angle CAB and angle DAC are supplementary. If the measure of angle CAB is 30, what's the measure of angle DAC? Right? Well, we can just do 180 minus 30 would get me 150, right? So because I know these two have to add up to 180, I can figure out what this angle measurement is. Okay, so the next thing I wanted to talk about is this concept of vertical angles. If we have a situation like this, basically where two lines are intersecting each other, it's going to create two pairs of vertical angles. This angle here and this angle here are going to have the same value, as well as this one and this one. And let's go ahead and kind of prove that to ourselves. Let's pretend that this has, let's make it easy. No, I won't do that. Let's make the math easy for us. Let's call this 50. Okay, so notice that here we have a straight line, meaning this angle and this angle are supplementary to one another, meaning they add up to 180. So if this is 50, this needs to be 130, right? Together they make 180. Okay, but then look here, we have another straight line. And these two, right, are also supplementary. So if this is 130, well, how much more do we need to get to 180? We need 50 more, right? And then finally, over here, we have our last straight line, meaning it's 180 degrees, right? Supplementary angles. And 50, we need 130 more to get to 180. So notice that in this situation, we have the two sets of vertical angles which have the same angle measurement. Okay? They can actually give you a problem like this where they force you to do some algebra. So they could say something like this: 3x plus 7, and then they say this is equal to 61, for instance, right? Okay, well, because these are vertical angles, we know that they must have the same value, which means I can write an equation. I can put them equal to each other, right? 4x plus 7 equals 61. Okay, and then from here we can just use algebra to solve for x. Let's take away 7. Okay, 4x is equal to 54, and then we divide by 4. X equals, well, 13.5. So then they might finally ask you, well, what's the measure of this angle? Okay, we need to cut that part out. Okay, the last bit of terminology that we need to talk about to get us started with geometry is this idea of parallel and perpendicular lines. Okay, they both have symbols that can be used to show it. Parallel is just two lines like this. It looks like 11. Okay, and then perpendicular is like this. So what parallel lines mean is that they could go on forever and they would never touch, right? They're like perfectly aligned, so they're not getting further apart, they're not getting closer to each other, they're going exactly the same direction. They're parallel. Okay? Perpendicular lines intersect at right angles. So these two lines, not perpendicular, right? Because this is not a right angle. But when we have two lines making like a perfect cross, right? Or like an intersection, a four-way intersection, we have 4 right angles. So these two lines here are perpendicular. Remember, this line, not perpendicular. Okay, so to wrap up this video, I wanted to take a look at one of the more complicated types of problems that you could be given involving lines, line segments, rays, and angles, and that kind of thing. So they could give you, this is all the information we're going to get for the problem. They say find the value of x. Okay, we have 2 angles, right? These represent the values of these 2 different angles. So what do we know? Let's call this angle 1 and angle 2. What do we know about angle 1 and angle 2? We know that angle 1 and angle 2 are supplementary, which means that angle 1 plus angle 2 will add up to 180. Okay? Now I have an equation. What can I put here in place of angle 1? Well, let's put the value we were given. 2 times 11x plus 16 plus 6x minus 20 equals 180. Okay. From here, now it's just an algebra equation that we need to solve, right? If you recall previous video, let's distribute. So 2 times 11, 22x, 2 times 16 plus 32 plus 6x. And then if we're adding a negative number, that's like subtracting, right? So minus 20 equals 180. Okay, we should always check, do we have any like terms to combine? Yes, 32 minus 20 gives me positive 12, and 22x plus 6x is 28x plus 12 equals 180. We take away 12, we get 28x equals 172. I'll put it over here. 28x equals 172. And then what's our last step here? Right, we're always going to divide by the coefficient of x. Divide both sides by 28. And we would get that x equals 6. Okay, thank you for watching. Like I said, this is just the first video on geometry, but I hope that it was helpful, and I will catch you in the next one.